Hello everyone. In this video we're going to be solving an interesting exponential equation. We've done a similar problem before. I'll share the links down below. We have 6 to the power x minus 2 to the power x equals 32, and we're going to be looking for x values. I'll be presenting two approaches. You can also call them methods if you want. And then we'll be looking at a graph at the end. So let's start with our first approach. For our first approach, I'm just going to define f of x as 6 to the power x minus 2 to the power x. And then I'm going to differentiate it. Why? Because I want to look at the behavior of the function. And a lot of times when we're looking for behavior of functions, such as whether they're increasing or decreasing on a certain interval, we do take the first derivative. So let's go ahead and do that. And the derivative of a to the x is a to the power x times ln a. If the base is e, we got a special case. It becomes e to the x, which is the function itself, because ln e is equal to 1. So that's a special scenario. Anyways, let's go ahead and differentiate this using the rules. 6 to the x will be 6 to the x times ln 6. And the second part will be 2 to the x times ln 2. And we're going to set this equal to 0 because we want to find where this function, or if this function has any horizontal tangents. In other words, critical values. Sometimes critical values are points where the derivative does not exist or the derivative is 0. So let's go ahead and put the 2 to the x on the right hand side. So we're going to get the following. And then divide both sides by 2 to the x. That's going to give you 3 to the x. And divide by ln 6. That's going to give you ln 2 over ln 6. Now, to bring down the x, we can go ahead and ln both sides one more time. By the way, I keep saying ln, like ln b is just log b with base e. E is Euler's number, which is about 2.7. That is the special number whose derivative is itself. Okay? All right. So let's go ahead and ln both sides. We're going to have ln of ln's, right? Ln of ln's, and x, you can go ahead and bring it down. X times ln 3 equals ln of ln 2 over ln 6. You can also write this as difference of ln's, but that's not super important. Now we want to find the critical value, the x coordinate. So let's go ahead and divide both sides by ln 3. And there you go. This is our x value, where the function has a horizontal tangent. Does it? Yes. When I show you the graph, you'll have a better idea. But for right now, let's go ahead and take a look at this value. Is this a positive value? Is this a negative value? What do you think? Okay, if you said negative, you guessed it right. Because ln 2 over ln 6 is less than 1. Obviously, 6 is greater than 2, right? And ln of a number that's less than 1, obviously this is positive, but less than 1 is negative. So you have negative divided by ln 3, which is positive, so this is negative. ln 3 is positive because 3 is greater than 1. Obvious, right? So what is that supposed to mean? So we have a negative x value, and what about the y value? If you plug it in, and let's call this x sub 0, by the way, and let's call the y coordinate y sub 0. So we do have either a maximum or a minimum. Let's go ahead and take a look at a couple other things, such as limit as x approaches infinity of 6 to the x minus 2 to the x. Now, obviously, 6 to the power x is going to grow much faster than 2 to the x, so this limit is going to be infinity. And sometimes we say limit does not exist, but basically, this function approaches infinity as x approaches infinity. Okay. For people who are very rigorous, you can probably make it more rigorous. Anyways, as x approaches negative infinity, what happens, right? Something different happens, because as x approaches infinity, think about it this way. 1 over 6 to the power negative x. As x approaches negative infinity, negative x approaches infinity. So 1 over infinity approaches 0. So this limit is 0. That exists. So we have a function that approaches 0 as x approaches negative infinity, so something like this. And then as x approaches infinity, it approaches infinity. So from this point to that point, or from this point to that point, we want to go. But we also need a maximum or a minimum point. So if I kind of go like this, you know, and at the negative value, y value is also negative, I need to have a maximum or minimum. So I can probably maybe go like this, but then I need to cross the x-axis. Is that possible? If you set the y equal to 0, you're going to notice that it actually happens. But if you set it equal to 0, you get x equals 0, because 1 minus 1 equals 0. So that happens here. You know what that tells you? Your function needs to go like that. It needs to go through here. It needs to have a maximum or minimum. So it's basically going to go through these points pretty much, right? But then what about the other piece? It's probably going to be coming from here, because it's not going to cross the x-axis again. Make sense? So we have a picture like this, which means it has a minimum at that point. Anyways, to keep a long story short, we have a one solution for this function, because at y equals 32, you're going to have a single intersection point, because our function is on this interval x0 to infinity. Our function is always increasing, therefore it is going to have a single intersection point. How do you find that value, right? Easy, just by guess and check. But here's the thing: we know that the intersection point is going to have a positive x coordinate. Therefore, we're going to be checking positive values. Can x be less than 1? Okay. What if x is something like 1/2? Okay, square root of x minus square root of 2. Do you think that's going to equal 32? No way. That's going to be a very small number. So x needs to be a little larger. How about x equals 1? 6 minus 2? Not there yet, but we're getting closer. How about x equals 2? Then we get 36 minus 4. There you go. Bingo. We got it. Okay, I know this is purely guess and check, but what can you do? You can't analytically solve this problem, right? You can do numerical methods, but that's it. Anyways, so x equals 2 is a solution, and that's the only solution. Let's go ahead and take a look at the second approach. So I'm going to rewrite my equation. Add 2 to the x to both sides. So all this effort was to prove that there's only one solution, and then we guessed and checked. Now, second approach, divide both sides by 6 to the x, that's the largest power. Divide by 6 to the x, divide by 6 to the x. You get 1 equals 2 over 6, which is 1/3 to the power x, plus 32 over 6 to the power x. Now notice that this is a decreasing function, and this is also a decreasing function. Their sum is also decreasing, right? Which means, and think about it, like you have a decreasing function and a horizontal line. They're going to intersect at a single point, which means you're only going to have a single solution. And that is at x equals 2, as we've seen before, because x equals 2 works. Awesome. Now let's go ahead and take a look at the graph, and we'll finish up. So the graph kind of gives you this picture, and notice that this beautiful point, right? This beautiful point is where f has a minimum. And by the way, you can pretend that this is y equals 32, not y equals 9, because I messed up on the graph apparently. Anyways, you get the idea, hopefully. X equals 2 is the only solution to this equation. Well, this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.